Hello class. In this video we're going to be talking about how to multiply whole numbers with fractions. Now while this skill isn't something we directly tested on, it is going to be an important skill you'll need in order to find scale factors and in order to construct new similar figures. Now I do want to remind you that if you are looking at this video, you need to take detailed notes. Whether it's on this video or any other videos that are happening in the future, if your notes are not detailed enough, I will ask you to redo the activity so that you get the full value of the video. Now, first I want to talk about multiplying fractions by fractions, and in this section I am going to go over cross-canceling for those who had difficulty with it when we were talking about it in class. Now, traditionally, we are only going to take a look at these first two fractions, and we're going to show you how multiplying just normally straight across, like as we usually do, can actually be a little bit more time consuming than just normal cross-canceling. So if you remember from class, when you multiply two fractions together, you multiply the numerators with the numerators and the denominators with the denominators. So here I can see that 3 times 5 is 15, and 5 times 9 is going to be 45. Now I can see from here that I do have a common factor of 5. I can reduce that down to 3/9, and I can see that 3 and 9 are also divisible by 3, and I'll eventually get 1/3. Now, while this may be easy for some students, it's actually a lot quicker to just do some cross-canceling, and you'll see why in just a moment. So on this side, I will complete this in blue. Now, this is the same problem as the previous example. 3/5 times 5/9. And what I'm going to do, instead of multiplying and then reducing, I'm going to reduce first and then multiply. So the reason they call it cross-canceling is because we're going to be moving across the fraction, so bottom left and top right. I can see that both the 5 and a 5 share a common factor of 1, so I'm going to cross out my original number and put a 1. And I can see that 3 and 9 also share a common factor of 3. So what I can do is divide 3 by 3, which will give me 1, and 9 by 3, which will give me 3. And just like normal, I'm still going to multiply across once everything is reduced. And you can see here it's a lot easier because now we're just multiplying 1 by 1, which is 1, and the 1 by 3, which is 3. So we still got the same result, but we got it much quicker and without having to do as much thinking versus this result. Now, if you would still like to multiply fractions like this and reduce later, that's fine. This is just a skill that might save you a little bit of time. Now, to show you the benefits of cross-canceling, I have two other problems that are a little bit more tricky. Now, in the green, I'm going to be solving this problem over here. And I should mention that if you are taking notes, don't worry about changing the color of your markers or anything like that. I'll be fine as long as these notes are in your notebook. Now I'm going to cross-cancel over here, and I can see that 36 and 9 share a common factor of 9. 9 divided by 9 is 1. 36 divided by 9 is 4. And I'm going to do this once more over here with 25 and 50. Now some people might say that there's a common factor of 5, but if you look closely, there's actually a larger common factor of 25. 25 divided by 25 is 1. 50 divided by 25 is 2. So now I'm just multiplying 4 by 1, which is 4, and 2 by 1, which is going to give me 2. And I can see even here that I can reduce this further to just say that 4 divided by 2 is 2. Now, in this example over here, which I will be doing in purple, again, I'll be showing an example of cross-canceling. Now, 18 and 27 share a common factor of 9. 18 divided by 9 is going to give me 2. Sorry for this little issue right here. And here, let me clear that up a little bit. Okay, sorry about that. So again, these two do share a common factor, which is 9. And 18 divided by 9 is 2. 27 divided by 9 is 3. Sorry for the mess over here. We can also see this over here with 14 and 28. So 14 divided by 14, which is our common factor, is 1. And 28 divided by 14 is going to be 2. So now that I'm multiplying my 2 with my 1, I have a numerator of 2. And for my denominator, I see that I have a denominator of 6. And I can continue to reduce this in order to get a fraction of 1/3. Now, for our next example, we will be multiplying fractions by whole numbers. And I just want to go over this really quickly because there are some students who don't see that whole numbers are actually fractions hidden in disguise. So all I'll have to do here is, instead of just saying 5 times 4/5, I'm going to say 5 over 1, because 5 divided by 1 is still 5, times 4/5. So I'm actually going to cross cancel, even though it's really not going to save me a ton of time here. But I know 5 and 5 share a common factor of 1. And so now I just have 4 times 1, which is 4. I have 1 times 1, which is 1. So I can see that my product of 5 and 4/5 is just going to be regular old 4. Now with examples like 6 times 1/4, while we are going to cross cancel and put a 1 under our numerator of 6, we're not going to get such a nice answer. So between here and here, I can see 6 and 4 share a common factor of 2. 4 divided by 2 is 2. 6 divided by 2 is going to give me 3. So now I'm just multiplying my 3 by my 1 and my 1 by my 2. I see I have an answer of 3 over 2, which is also equivalent to 1 and 1/2. Now, for your assessment, I would suggest keeping your fractions in improper fraction mode, and you'll see why in a later video. Now, these examples are going to be very important, especially when you are trying to construct similar figures. So what I like to do when I solve problems like this is I see a big common mistake between students. Now, I do notice that a lot of students will say, oh, well, we have 4 times 8, which is 32, so my answer is 32.5, which is not the case, because this is 4 times 8.5, not just 4 times 8 plus a half. So what we can do in order to correct this common mistake is we're going to put a little line in between the 8 and the half, and now we can see that these are two separate problems. So what I'm going to be doing is just multiplying 4 and 8, which is going to give me 32. And then what we'll be doing on the right side is we'll be multiplying 4 over 1 times a half. And now I do see that, again, I got 32 on this side. And when I am done multiplying 4 times a half, I'm just going to get 2. And now what I will do to get my final product is I will add these together, and I will receive a product of 34. Now in this next example, we have 9 times 3 2/3. So again, I'll be separating these, the whole number and my rational number by fraction over here with a little line. I know that 9 times 3 is 27. And then I'll also have to multiply 9 times 2/3. So again, I'm going to put that over 1. And I'm going to try to save some time by cross-canceling. So a common factor between 3 and 9 is going to be 3. So now I have my 3 divided by 3, which is a 1. 9 divided by 3, which is 3. 3 times 2 is going to give me 6. 1 times 1 is going to give me 1, or just a regular old 6. So now what I'll be doing is adding 27 with 6, and I'm going to get a final product of 33. Now, I would suggest on this example that you pause the video and try this on your own just to test your own skills. And in about 5 seconds after, so pause the video, and in about 5 seconds I will be talking about how to solve this problem. Now that you've had some time to work on this problem on your own, let's solve it together. So we do have 5 times 3 and 2/5. I'm going to separate my two problems. So I know 5 times 3 is 15. And 5 times 2/5. So what I'll be just doing is cross-canceling here. 5 and 5 also obviously share a common factor of 1. And when I multiply, I'm going to see that I have a fraction of 2 over 1, or just 2. So I'll be adding 15 plus 2 in order to get my total product of 17. This is the conclusion of the multiplying fractions video. If you have any questions or comments, please feel free to write them in your notebook and ask me tomorrow. Thank you.